This video, we're going to take a look at exponents, and that's going to include the product rule of exponents, like what do you do when you're multiplying by the same base with the exponents. We're going to look at power rule for exponents, so it's a power to a power, and some things with division, so quotient rule, and then when we're dividing by some values. So let's start off by just talking about the product rule. So the product rule is when we are multiplying two values with the same base with some exponents. So let's say it's x squared times x to the third. In order to understand the rule, let's just understand what's happening here. If I'm doing x squared times x to the third, what that is I'm doing x times x to represent x squared, and then I'm multiplying that by x to the third, which is x times x times x. So this is x to the third. So how many x's do I have being multiplied together? I have 5 of them, so this is going to be x to the fifth. Well, rather than writing out 5 x's being multiplied together, we could use this product rule that says x to the a times x to the b, or any sort of base, we would just add the exponent. So x to the a plus b, and that's anything. So y to the a, y to the b, 3 to the a plus, times 3 to the b. You just add the exponents. So we're multiplying by the same base, you add those exponents. Let's use the product rule. So on number 1, 6 to the fifth times 6 to the third, that is going to be 6 to the 5 plus 3, because we are multiplying by the same base, and that's going to translate to 6 to the 8th. And you could translate that into the actual value of what is 6 to the 8th. It's going to be a big number, but I'm just going to leave it as 6 to the 8th, because I want to just talk about the process here of just making sure we understand how to get to 6 to the 8th. We're multiplying by the same base, so we add those exponents. It's 5 6's being multiplied, 3 6's being multiplied. So how many do I have in total? 8. Over here, number 2, 12 to the first times 12 to the sixth. That is going to be the same base because they're both 12. This is 12 to the first. The exponent here is a 1. Even though there is no exponent, that's a 1. So we have to make sure we understand that this is 12 times 6 more 12s. So how many do we have? Well, we have 12 to the 1 plus 6, which is 12 to the 7th. So you get 7 12s there, so 12 to the 7th. Common error here is the pretty straightforward route of seeing like, oh, I have 6 and 6, so I'm going to make that 36 to the 8th. I'm going to multiply 6 and 6. No. The 6 to the 5th is a number. 6 to the 5th is a number. 6 to the 3rd is a number. What we're doing is we're keeping it in exponential notation to translate 6 to the 8th being a much bigger number in a much more condensed fashion where it's not just writing out a gigantic number. So that's why we're not doing 6 times 6 to get 36. Because 6 to the 5th is being represented by 6 base with an exponent of 5. So I'm not doing 6 times 6. Same thing over here. I'm not doing 12 times 12 to get a 144 raised to the 7th power, because this is 12 to the first times 12 to the 6th. So it's really 7 12s being multiplied out. So it's 12 to the 7th. I don't know why that all got erased. Let me just fix this up. 12 to the first times 12 to the 6th is 12 to the 1 plus 6, which is 12 to the 7th. Okay, moving on. X to the second times x to the 9th. That's going to be x to the 2 plus 9. So x to the 11th. Make sure your bases are the same. Look at number 4. X to the second times y to the 5th. We have different bases, so we're not multiplying anything together. So the answer is just x squared y to the 5th. They are not the same bases. So we can't just add the exponents. And then here, number 5, 5 to the second, 5 to the second, 5 to the third, all the same base of 5. So we're going to do 2 plus 2 plus 3 to get 5 to the 7th. 2 plus 2 is 4, plus 3 is 7, so we get 5 to the 7th. Be careful with number 6. We have the base of -4 and -4, and they're both being multiplied. And we have some exponents, so this is going to become -4 to the 2 plus 6, which is -4 to the 8th. So -4 to the 8th power. Which, if we were actually to translate this answer, like go from -4 8th to the actual form that it is, this would be a positive number, not a negative, because it's a negative being raised to that positive, to that even exponent. So that's going to become a positive, not a negative. So it's something to think about there. Now let's simplify some expressions. So the difference here with these problems here is we have these coefficients in the front. So what do we do when we have coefficients? We do the same thing. Whatever power it is, whatever operation, excuse me, not power, whatever operation, 2 times 5, we're going to do 2 times 5 to get 10. So I'm just doing 2 times 5. I'm just multiplying the coefficients together. And then we do the same thing with the variables. So it's x to the 4th times x to the 3rd. So x to the 4th times x to the 3rd is going to be 4 plus 3 because they're the same base. So we get x to the 3 plus 4 is 7. So with the coefficients of 2 and 5, I just perform the operation. 2 times 5 is 10. And then I add the exponents on those same bases because we're multiplying by the same base. Add the exponent for 4 plus 3. Number 8, negative 2 times negative 8. That's just going to be a negative times a negative is a positive. 2 times 8 is 16. M to the, so this is m to the 7th times m to the 9th, which is going to be 7 plus 9, which is 16. So 16m to the 16th. Careful here. So this one is just negative 3, and then I don't have any other coefficients because technically the coefficient here would just be a 1. So I technically don't have any other coefficients, so I'll just leave this as negative 3. And then I have x to the 5th times x to the 2nd. So that's going to be x to the 7th. 5 plus 2 is 7. And then y to the 7th times y to the 8th. That's going to be 7 plus 8, which is 15. So that ends up being negative 3 x to the 7th, y to the 15th. Number 10, 9 times negative 9 is negative 81. And then I have x to the 6th times x to the 9th. Be careful, don't let the order fool you. That's a y, so you want to make sure you're doing x to the 6th times x to the 9th. So that's going to be x to the 6 plus 9, which is 15. And then I don't have anything to do with the y to the 5th, so I'm going to leave that alone. So I just leave that as y to the 5th. So negative 81 x to the 15th, y to the 5th. Number 11, same thing. Negative 3 times 5 is negative 15. And then we have a to the 3rd times a to the 1st. That's just a, so that's a to the 1st. So that's a to the 3 plus 1 is 4. And then b to the 2nd times b to the 4th. 2 plus 4 is 6. So negative 15, a to the 4th, b to the 6th. So that was product rule. Product rule when we're just multiplying by the same base. Multiplication of the same base. Now let's look at the power rule when we have a power to a power. So let's just generalize this to like x to the 2nd to the 3rd, let's say. So if I have x to the 2nd to the 3rd, that is an exponent. So if I had like 3 to the 3rd, 3 to the 3rd is 3 times 3 times 3, right? It's just, the exponent tells us how many times we multiply the number together. So if I have x to the 2nd to the 3rd, that's going to be x squared times x squared times x squared. Because it's x squared being multiplied 3 times. Well, what did we just look at with multiplication of the same base? We looked at adding the exponents. So this would become x to the 2 plus 2 plus 2. So it ends up being x to the 6th. 2 plus 2 is 6. So how can we go from here to here without having to do all of this in between work? Well, if we notice power to a power, I can just multiply 2 times 3 to get 6. So rather than writing it all out as a product rule, I can just use this power rule, which is x to the a to the b is just x to the a times b. You multiply those exponents together. So 5 to the 4th to the 2nd is going to be 4 times 2. Because I have a power to a power. So it's 5 to the 4th times 5 to the 4th, which is just 4 plus 4. So that's going to be just the same thing as multiplication. So 5 to the 8th. Number 13, x to the 2 times 5 is 10. So I'm multiplying 2 times 5, power to a power. Not to be confused with x to the 2nd times x to the 5th. These are two different problems. When we have this scenario of x to the 2nd times x to the 5th, that is 2 plus 5 to get 7. So here is just x to the 10th. Now 14, and moving on to the rest of these, notice that I have 2z to the 4th. So I have multiple terms being raised to that exponent. Well, again, just think about what's happening logically. This is 2z times 2z times 2z times 2z, right? Because it's 2z being multiplied to the 4th power. So it's 2z being multiplied 4 times. So I don't want to write that all out because I don't want to use product rule. what we're doing is we're just raising 2 to the 4th power and z to the 4th power. So this is 2 to the 1st, z to the 1st to the 4th. So I'm just raising each of these to the 4th power. So this becomes 2 to the 1 times 4 and z to the 1 times 4. So each of those terms are getting the exponent of 4. And since both of these exponents are just 1 as it is, so this is 2 to the 1st and this is z to the 1st, it's just 4 times 1 and 4 times 1. If it was 2 to the 2nd or 2 to the 3rd or z to the 5th, you would do 4 times 5 or 4 times whatever those exponents are. But in this case, since they're both 1, it's just 1 times 4 and 1 times 4. So this ends up being 2 to the 4th and z to the 4th, right? 1 times 4 is 4. And then we do actually want to start converting now that we're getting into some multiple steps. So 2 to the 4th is 16. So this is 16z to the 4th, because we're going to be multiplying multiple things together here in a second. So let's just get in the habit now. So that's 16z to the 4th. 15 is going to be negative 4g to the 5th to the 2nd. So that's negative 4 raised to the 2nd power, because this is a 1, negative 4 to the 1st power. And then g to the 5 times 2, which is 10. So negative 4 to the 2nd power is negative 4 times negative 4, which is positive 16. G to the 10th, 5 times 2 is 10. Number 16, 3 to the 1st, x to the 1st, y to the 2nd, all being raised to the 4th power. So everything is getting that exponent of 4. So this is going to be 3 to the 1 times 4, x to the 1 times 4, and y to the 2 times 4. So 3 to the 1 times 4, x to the 1 times 4, and y to the 2 times 4. And if you're having trouble with that process, like understanding why is that, just think about what's happening. This is 3xy squared times 3xy squared times 3xy squared times 3xy squared. It's 3xy squared being multiplied 4 times. So it's 3 times 3 times 3 times 3. It's 4, 3 is being multiplied. So that's why we have to get that exponent. So 3 to the 1 times 4 is 4. X to the 1 times 4 is 4. And then y to the 2 times 4 is 8. 3 to the 4th, let's take care of that. 3 to the 4th is maybe 81. Yeah, 81. So 81. X to the 4th, y to the 8th. These next two problems, 17 and 18, I like these problems a lot because this really helps us understand the differences between the power rule and the product rule. So on 17, I have n to the 2nd to the 3rd times n to the 7th. So first of all, I have this power to a power. So I have to do the power to the power first. I have to do n to the 2 times 3 because it's a power to a power. And that's multiplication. So 2 times 3 is 6. So then I have n to the 6th times n to the 7th. So how do I do this? Well, it's multiplication of the same base. That means I have to add the exponent. So I'm going to get n to the 13th there because I'm multiplying by the same base, which means you add. So first, we did the power rule, power to a power, and then we had to use product rule. So we used both sets of rules on this one. And then 18 is pretty much the same thing, just a little bit more advanced, where we have 2 to the 1st, x to the 3rd, y to the 5th, all being raised to the 3rd, and then we're multiplying by x to the 4th, y to the 5th. So this becomes 2 to the 3rd, because this is exponent of 1, 1 times 3, x to the 9th, 3 times 3, and y to the 15th, 5 times 3, times x to the 4th, y to the 5th. Quite a bit of some cleaning up to do here. So first of all, 2 to the 3rd is 8, 2 times 2 times 2, so that's 8. And then I also have x to the 9th times x to the 4th, which is going to be x to the 13th. And then I have y to the 15th, y to the 5th, which is going to be 15 plus 5, which is 20. So 8x to the 13th, y to the 20th. Okay, let's move on. Quotients now. So power of a quotient. There's a couple ways you could think about this, but what I like to just start off by thinking is if I have, let's just do the examples, like number 19. X over y to the 2nd power. Think about what's happening. You don't have to sit here and rely on rules. Just think about the logic behind what's happening. This is x over y times x over y. So it's x times x, y times y, right? So that's just going to become x to the 1st, y to the 1st. So this is going to become x to the 1 times 2 and y to the 1 times 2. So everything is just getting that exponent. That's all that's happening. Everything is being raised to that exponent. So this is x to the 2nd and y to the 2nd because it's x over y squared. So x over y times x over y comes out to be x squared over y squared. And then 20, same thing. This is going to be x to the 3 times 2 over 3 to the 1 times 2 and y to the 4 times 2. So everything is getting that exponent of 2 because it's being raised to the second. So this would be x to the third over 3y to the fourth times x to the third over 3y to the fourth. So it's just squaring each one or multiplying by 2. So x to the sixth over, and then 3 to the 1 times 2 is 3 squared, which is 9. And then y to the eighth, 4 times 2. And that one would be done. So the power rule of a quotient is just making sure everything is getting that exponent. It's the exact same thing as if you had 2xy to the third power. This would become 2 to the third, x to the third, y to the third. Everything is getting this exponent. Quotient rule for exponents. Now this is a little bit of a rule here that we have to write down. So if I had, let's say, x to the third over x to the second. So if I'm dividing, look what's happening. X to the third is x times x times x. X to the second is x times x. Well, if I have, let's say I had like 5 over 5, what does that simplify down to? 5 divided by 5 is 1 because the 5's cancel out. Same thing happens here. X over x is 1. X over x is 1. So I have a pair of x's that cancel out, leaving me with just x to the first on the top. So I just have x to the first on the top. How do I get that? Well, instead of actually writing out this whole division, I can just subtract. So if I had x to the a over x to the b, I could just rewrite this as x to the a minus b. I could just subtract the exponents rather than writing out the division, canceling out some terms. It's just subtraction. So if I had x to the 3 minus 2, what do I get? I get x to the first. Boom. So let's go ahead and do this. So 21, x to the third over x to the first. So this is going to be x to the 3 minus 1. And then I have y to the 7 minus 3, because it's the x's here. And this is exponent of 1, 7 minus 3. So x to the second, y to the fourth. And then I have negative 4, 6 minus 3 is 3. So this was negative 4 to the 6 minus 3, which is 3. And then we do want to actually evaluate that. So let's do negative 4 to the third power, which is negative 64. Next two, kind of tough. So on 23, I have a lot going on the inside, and then I have this exponent of 3. There's two ways of doing this. You can take this 3 to everything right now, and then simplify. That creates a little bit of a headache though, because the numbers will get a lot bigger because we're raising 2 to the third, 4 to the third. So let's just condense the inside. I'm able to condense the inside because I notice 2 and 4, that's a fraction. 2 and 4, 2 over 4 is 1/2. So I'm going to simplify that down. So that's 1/2, right? Because it's 2 over 4 simplifies down to 1/2. So I'm going to simplify that fraction just like normal. And then I also have x to the 9th over x to the third. That could be simplified because we have an x on top and an x on bottom. That's going to be 9 minus 3, which is 6. So I get x to the 6th. I don't have anything to do with the y, so I'm going to leave that as y to the 4th on the bottom there, and that is being raised to the third power. Now that I cleaned up all of that, now it makes it a little bit easier. So on the top, I have 1. 1 to any power is just 1, so I'm not even going to bother with that. But then we have to do x to the 6 times 3, which is 18. On the bottom, the 2 needs that exponent of 3, because that's a 2 to the first. So 2 to the 1 times 3 is 3, so 2 to the third. And then I also need to bring that to the y. So y to the 4 times 3 is 12. So the only simplification that can be made is that 2 to the third is 8. So x to the 18th over 8. Y to the 12th. And see how much more manageable that was? Where before, this would become 2 to the third power over 4 to the third power. So then you'd have 8 over 4 to the third, and then you'd have to do x to the 27th over x to the 9th. Like that just gets things a lot more complicated. So that's why I want, if you're able to simplify the inside of the parentheses, do that, and then raise the exponent. And then 24, here we have a power to a power on the top. I have this, power to a power on the top. And then I have it being divided by that term. Notice the differences between a question like 23 and a question like 24. Look at these two questions. See how in 23 all of this was in the parentheses? And then it was raised to the exponent? So this I was able to simplify because it's all in the parentheses. But here, only the top is in the parentheses being raised to this exponent. So my only route right now is to just raise everything to that exponent on top, at least, where that's being raised to the second power. So this is going to become 6 squared x to the 2 times 3 is 6, and then y to the 2 times 2 is 4, over 6x to the third y to the second. That's my only route, because all of this is being raised to the second power, not the bottom, only the top. There's 2 ways of going about simplifying this. The first route is you could do 6 squared, which is 36, and then 36 divided by 6 is 6, or 6 to the second over 6 to the first. 6 to the 2 minus 1 is 1, so you get 6 either way. And then x to the 6 minus 3 is 3. And then y to the 4 minus 2 is 2, so y squared. So 6x to the third y squared. Last one, 0 exponents. Let's just think about what's happening here before I just kind of give you the rule. If I had x to the 5th over x to the 5th, what did we just talk about? We talked about subtraction. So I would do x to the 5 minus 5, which is x to the 0. So then we end up with the 0 power. But before we just define what this is, think of it this way. I'm just going to change to x to the second over x to the second. If I had x to the second over x to the second, here's what's happening. X to the second is x times x, so x is canceled. X is canceled. What am I left with? 1. Just 1. Not 0, just 1. If 2 numbers cancel out, like if you had 5 divided by 5, that's 1, not 0. So we end up getting 1. Same thing's going to happen. What if it was x to the 5th over x to the 5th? Same thing's going to happen. 1, because everything cancels out. So what is x to the 0 power? 1. Anything to the 0 power is 1. A to the 0 power is 1. Any number to the 0 power is always 1. So 25, x to the 0, 1. 10x over 100y raised to the 0 power. I don't even care what's happening on the inside here because the entire parentheses is being raised to the 0 power. Therefore, the answer is 1. No matter what is going on, the entire statement is being raised to that 0 power, so the whole thing's 1. And 27, 5y to the 0 power. The entire parentheses is being raised to the 0 power, so that's 1 again. 28, little bit of a trick here. It's 5y to the 0 power. What is being raised to the 0 power? Only the y. Only the y is being raised to the 0 power. Notice the differences between these two questions. This is in parentheses 5y to the 0 power. This is 5 times y to the 0 power. So this becomes 1, and then I'm multiplying that by 5. So the answer to 28 is 5 because only the y is being raised to the 0 power. So you get 5 for that one because it's 5 times 1. Y to the 0 power is 1. All right. Good section here. A lot of important rules.